Swayam Prabha. Digital India. Educated India.
Welcome back. Let us continue the applications of refrigeration. So, we have seen the applications refrigeration in storage like short-term, long-term, frozen storage. So, when it comes to the food preservation, so here I have just given a table, a different food category, fruits. For example, if you take fruits, the average storage life is, if it is stored at 0 degrees centigrade, it is about 6 months. Whereas if we don't go for a controlled environment, if it is storing at normal condition at 30 degrees centigrade or maybe slightly less than the ambient condition, 12 to 14 days, because in summer the temperature goes up to 40, 45, 50 also. So we can see that significant increase in this storage life of fruits, which is, if it is stored at 30, if it is stored at 0 degree, there is a significant improvement in the storage life compared to the same product if it is stored at 30 degrees centigrade. If you take leafy vegetables, the average storage life, normally it is week maximum, about 4 to 5 days at 30 degrees centigrade. At 0 degrees centigrade, it comes to 20 days. It's about 4 times. Poultry, normally we cannot even store it for a day. It gets spoiled. So under refrigerated condition at 0 degrees centigrade, we can have for about a week to 3 weeks. Meat is again 5 to 10 days, which is less than a day if the temperature is 30 degree. Fish also about a week, 3 to 7 days, which would be otherwise less than a day. We cannot even store it for a day. So this is some of the category of food items comparing the average, storage life at 0 degree with that of 30 degrees. Let us see the other applications. Before seeing this one, normally the storage life of the product, the storage life of the product depends upon, be it a vegetable or fruits, it depends upon 2 factors as I discussed in the previous one. It depends upon the moisture content, that is the humidity, how much humidity is present in the product, and apart from that, when it is about to be stored, what is the condition at the time of storage? What is the condition at the time of the shelf life? The storage life of the item can be enhanced only under refrigerated conditions. Now let us see the other applications. Before seeing the other applications, I'll just go to one of the previous applications where I was telling about the dehumidification of air. Normally in this one, dehumidification is the removal of moisture from the air. So when we cool the air below dew point, the moisture content or the water vapor starts condensing. That is called the dew point. Dew point is the temperature at which the water vapor in the air starts condensing or about to. So here the temperature of the air is less than its dew point temperature. Dew point and when it comes to the recovery of solvents, I told some of the chemical during the chemical reaction, in chemical processes, the solvents normally gets evaporated or decomposed. So that can be recovered using refrigeration process by condensing at low temperature. Okay, so that point I would like to add. By condensing at recover the by condensing at low temperature. Yeah, to recover the decomposed solvents, let me write this one. By condensing at low temperature. Example is we can take acetone during the film manufacturing. Acetone is one example. Then CCl4 in textile industry are some of the examples. Let us move to the other applications. So here if you see, the first one is cold treatment of metals. So cold treatment is nothing but exposing the metals to sub-zero temperature or negative temperature, that is below 0 degrees centigrade. So normally in the temperature range from -80, -75 to 85, -85 or -90. This is done in order to improve the properties of the metals, like wear resistance, dimensional stability. So for this, refrigeration is required. So this is nothing but this is done to improve the properties of metals such as you can have you can add hardness also, hardness, wear resistance, dimensional stability, and for improving the dimensional stability. So normally this is done at a temperature of say -80 degrees centigrade to -85 degree centigrade. Like the metal will be soaked, soaking process will be taking place. So this is about cold treatment of metals. The second one is medical application. We have plenty of applications in medical. For storing vaccines, medicines, blood samples, test specimen in the laboratories, in labs, etc. Okay, so I mean these are very few applications. There are plenty of applications. Blood bank, refrigeration is used. So next one is ice skating. So that is in sports, ice skating sports. Instead of producing ice naturally, instead of depending on the weather, the water can be freezed into ice. Construction. So let us see how the refrigeration is used in construction. In construction, it is mainly used for during the setting of cement. So what happens? Cold water or chilled water is provided. Otherwise, what will happen if it is not provided? There are chances that it will expand. The concrete will expand, and there could be some cracks, formation of cracks. So to prevent that, cold water or chilled water is used for in the construction for the setting of cement. Okay, so cold water, chilled water, cold water is used. Cold water is used to prevent crack formation. Crack formation. And desalination of water. We know the desalination, the seawater is converted into, fresh water, like for drinking purposes. So what happens is the seawater is freezed into ice. Seawater is freezed into ice. Desalination of water. Desalination of water, it is a term which is used to convert the salt water into potable drinking water. So the seawater is converted into ice. When it is converted into ice, what happens is the salt content reduces. The salt content reduces. It is not free from salt. The salt content reduces. And by thawing process is the opposite of freezing process. Again, the ice will be separated and the fresh water can be produced. Fresh water can be produced. Seawater is freezed into ice, which is then converted into fresh water by thawing process. THAWING. Thawing process. Thawing process is opposite to freezing process. Opposite to freezing process. Let me emphasize again, I have made a presentation with regard to the refrigeration applications only on few applications. The applications are not limited to the points whatever I have covered. There are plenty of applications of refrigeration apart from what I have mentioned. Though the topic is refrigeration applications, in order to make the topic more interesting, to make the learners to have some interest, more interest, so I have taken a case study. It's a very small numerical, this one. So I will be solving this one. With that, after that, this lecture will be complete. So in a dairy industry, to process 65,000 liters of milk per day, following duty will be required. To cool milk from 30 degrees centigrade to 4 degrees centigrade in a plate chiller at the rate of 10,000 LPHs liters per hour. Next one is to pasteurize milk from 18.2 to 4 degrees centigrade in a plate chiller at the rate of 10,000 liters per hour. So this is the problem definition. So we are going to see which one, using direct expansion system, how much is the total refrigeration load. In the application of refrigeration, when I was discussing about the application in dairy, I was mentioning that the supply of milk, that is the demand for milk, is more in the morning than in the evening. So even if you look at this case study, 60% of the milk is received in the morning, whereas the remaining 40% in the evening. That means the refrigeration load is more in the morning compared to the evening. So let us, total quantity of milk is given as 65,000 liters per day. 65,000 liters per day. This is the data given. And morning, the quantity is 60%. That means 60% of 65,000, that is equal to 39,000 liters per day approximately, which comes to approximately 39,000 liters per day. And similarly in the evening, it is the remaining 40%. So 40% of 65,000, which comes the remaining 65,000 minus 39, that's about 26,000 liters per day. So I'll be calculating the refrigeration load for two cases. One is using direct expansion system, another one is ice bank system. Ice bank system. So let us use the first, let us take case 1, direct expansion system. Direct expansion system. So let us take the refrigeration load, and if you see, two duty have to be performed. One is cooling the milk from 30 to 4, and then from pasteurization process starts from 18.2 to 4 degrees centigrade. So one is cooling from 30 to 4, 30 degrees centigrade to 4 degrees centigrade. Pasteurization process, 18.2 degrees centigrade to 4 degree centigrade. So two things are there. Two processes are involved. So we have to calculate the refrigeration load. For the cooling process, that is, let us take Q. So first I am going to calculate the refrigeration load for the cooling process. So that is the basic equation, mCp delta T, m into Cp into delta T. Mass, that is volume into specific gravity, volume into specific gravity, because the volume is given, into Cp into delta T. So volume is 65,000. We'll take the total volume. Morning 39,000 liters per day, and afternoon, evening 26,000. So total 65,000. So 65,000 into 1.01 into Cp value. I think I will substitute directly, 0.93. This is the Cp value. This is specific gravity, 0.93. Delta T is from 30 to 4. So cooling from 30 to 4. So that is 30 minus 4. So it comes to, so it is in, I calculated in kilocalories per hour. So 2,44,218. 2,44,218 kilocalories per. So the specific heat capacity is in kilocalories. It is not in kilojoules. We can convert the kilocalories into kilojoules. 1 kilocalorie is 4.18 kilojoules. So this is Q. And similarly for the second one, that is for the pasteurizing process, only the delta T will change, 18.2 to 4. So this is Q is equal to mCp delta T. This is for cooling process. This is for cooling process. And this is for pasteurizing process. So yeah, again m is equal to volume into specific gravity, volume into specific gravity, Cp into delta T. So here it is equal to 65,000 into 1.01 into 0.93. Delta T is from 18.2 to 4. 18.2 minus 4. It comes to 1,33,380. 1,33,380 kilocalories per hour. So now the total refrigeration load is, before that, total refrigeration load is total refrigeration load is equal to 2,44,218 plus 1,33,380 380. Let us see the total. 3,77,598. 598. So both these values are in kilocalories per hour. So assuming a safety of 10%, normally the system is not designed exactly for the requirement. Factor of safety, say about 5 to 10% is taken. So considering 10% factor of safety, the 1 kilocalories per hour, considering 10% safety, factor of safety. So we can convert the kilocalories per hour into tons of refrigeration. So it comes to 137.35 TR. 137.35 TR. The total refrigeration load comes to 137.35 TR. So we can convert the kilocalories per hour into TR. The factor is, let me write it here. 1 TR is equal to 210 kilojoules per minute. This I have mentioned even in the units of refrigeration in the very first, in the initial lecture. I think maybe lecture 1 or 2. I think in the first lecture. So 1 kilocalorie is 4.18. So if you divide by this 4.18 or 4.2, we will get 1 TR is equal to around 50 kilocalories per. So now we can convert this into multiply by 60, you will get 3000 kilocalories per hour, 1 TR. So therefore 1 kilocalorie per hour is 1 by 3000. 1 kilocalorie per hour is equal to 1 by 3000 TR, which comes to 0.00033 TR. So when we multiply this 415357, we'll get this value. So this is the total refrigeration load if you are using a direct expansion system. Now let us see if you are using an ice bank system. So the specific gravity and the CP value remains the same. So we'll calculate the same thing for a ice bank system. Sorry, using ice bank system, we are calculating this one. This is per day. Ice bank system. STM. So this is the first one, refrigeration load for the cooling process. MCP delta T. Okay, all the values are known. So if you calculate this one, volume of the milk is 65,000 liters per day. Specific gravity, no change, 1.01, which we used for the previous calculation. The CP value is 0.93. The cooling process is from 30 to 4. So when you calculate, you will get 16,18,851. 16,18,851. 18,851 kilocalories per day, not hour. That is for a period of 24 hours. And this, for the second one, that is for this is for cooling process. This is for cooling. For pasteurizing, process. Again, we have to calculate MCP delta T. So here delta T is from 30 to 4. 30 to 30 minus 4, like this, 30 minus 4. And for the second case, it is 18.2 minus 4. So when we calculate, we are getting 884 141. 884 141 kilocalories per day. Okay, this is for per day. So the total refrigeration load is equal to 16, 18, 851 plus 884, 141, which comes to 2502,992. 2502,992 kilocalories per day. So again, considering a safety factor of 10%, considering a safety factor of 10%, the total refrigeration load is equal to 2753,291. 2753,291 kilocalories per day. So we can convert it into TR. First convert it into R. This is for 24 hours. So convert it into kilocalories per hour. Then convert the kilocalories per hour into tons of refrigeration. We will get 56.9. 56.9 TR. So when we are using an ice bank system, so the total refrigeration load comes to 56.9 TR. Including the factor of safety of 10%. And for a direct expansion system, we are getting 137 TR. So if we go for an ice bank system, the refrigeration load comes down drastically. When we compare with the direct expansion system, which has got 137 TR, and it's about only 57 TR, which is about 2 to 2.5 times less than the direct expansion system. So with this, the first module, as I told, the application of refrigeration is the last topic in the first module. With this, we come to the conclusion of the first module. I will meet you all in the second module. Thank you.